How to do the penny boat lab. So you should have gotten an instruction sheet on how to do it. You need to take, there's going to be a stack of aluminum foil. You take one piece only. If you take more, I'm going to run out. If we run out, you're going to have to cut your own 15 centimeters by 15 centimeters. You can get, that's half a foot, so 6 inches by 6 inches. You can then share the other half of that with your partner. So just tear a small strip, rip in half, then cut that in half again. So take a piece. Probably the first thing you're going to want to do is you're going to want to shape it like a boat. Now your boat could look something like that. It doesn't have to look the prettiest, or you can try to be a little bit more boat-like and build something like that. So once you build your boat, you say, okay, that's my boat. That's the boat I'm going to want to test. You're going to have to make sure you find the mass of it. So you're going to take it, you throw it on the balance, make sure it's 0, find the mass, record it on the back where it says the mass of the boat. Make sure you convert to kilograms. Everything has to be in kilograms. We record in grams, but we use our kilograms for our calculations for everything. Because when we find F of G, it's mass in kilograms times gravitational acceleration, 9.8. But everything has to be converted into kilograms. So we have the mass of our boat. We recorded that. When we go through and we do the buoyancy equation, I'll show you this in a different video. But the volume of your boat, which is one of our blanks that it's asking for, the volume of our boat is going to equal the amount of water that your boat displaces. So in our buoyancy equation, where we have the density that's displaced, what gets pushed out of the way, the water, how much water gets pushed out of the way, that's the volume of your boat. And then we're going to take that times G. But in order to determine the volume of the boat, we have to determine how much basically water our boat can hold. We can't just go length times width times height. So we're going to figure out the volume of our boat by actually filling our boat. So we found our mass already because we want to find the mass of our boat dry. Then we're going to take it, and throughout the rooms on the different lab tables, there are some containers of water. By the containers of water, there are some graduated cylinders. Note that I don't have this graduated cylinder completely full because you need to know how much volume you put into the boat. So I filled it with water, and I put it down to 100 mils of water. And then what I'm going to do is I'm going to fill my boat with water. And I'm going to try to figure out how much water it can hold. And what's going to happen as it's moving, you can kind of go through and you can say, well, this side's a little low. And you can shift how that water is laying in there a little bit. And you're going to keep filling. Now, due to surface tension, your boat probably will not go underwater. It's going to just kind of be like right on that verge of sinking. So right here is my low spot. Right there, if we look really, really carefully, we're right like at that borderline of if I had a little bit more water, the water in my tank is going to overcome it. So as of right now, I've put in the volume left on my graduated cylinder is 31 milliliters. So I started at 100, I'm at 31. So that means I have I use 69 milliliters of water in my boat. Now I can try to add a little bit more, and as I do, I'm going to very carefully look and say, now am I below the water? And the answer is, yeah, I'm below the water. So how much water could my boat hold? My boat could hold 69 milliliters of water, so I would put 69 milliliters of water right there. Then if you note right here, there's a conversion factor for milliliters of water to cubic meters, because our density formulas and our volumes have to be in cubic meters, and our densities are in kilograms per cubic meter. So this, we have to do a conversion factor, and you see my boat now sink. The surface tension wasn't enough to hold it up anymore. So convert milliliters to cubic meters. Remember, milliliters have to cancel out, so milliliters are on the top, so you got to put milliliters on the bottom. Do that conversion. So that'll give you your total volume of the boat. Because that's your total volume of your boat, that will give you the volume of water that was also displaced by your boat. I give you the mass of a penny. We have to convert that into kilograms as well. But that's how you go through and you kind of get those measurements. I'll show you next how to actually go through and test your boat. one thing I forgot to mention, after your boat sinks, you're going to want to pull out your boat and kind of shake it out. You're going to want to try to get as much water as you can out of it, because you want this thing relatively dry. But if you use paper towel or you do grab this too much, you're going to change the shape, which is going to change the volume. So you want to be kind of careful of that. Just kind of shake it out the best you can. You can give it kind of set upside down, give it a little bit of time while you're doing some calculations maybe along the way, but try to get as much water out as you can without changing the shape of your boat.